Let's talk about tautomers. So tautomers, really, really important in biochemistry, nucleic acids, and lots of different stuff. Tautomers are isomers, but they're linked by a common conjugate base, and they're often in equilibrium with each other. And so this comes out of our talking about this really stabilized conjugate base, right? So if I look at this we said that these protons in the middle are pretty acidic because I can spread that charge across a pretty big space, like 5 atoms. And all 3 of these are resonance structures of each other. And I made it less symmetrical. So this one is actually different than that one. Now, if I add a proton back to get to the neutral compound, I could add that proton here, or there, or there. In which case, I would get 3 different molecules. These are isomers of each other, but they are not the same, right? This one has 2 hydrogens in the middle. This one has 1. This one has 1. So these are all different. They might interconvert, might, probably, but might. And so this is not a resonance arrow. This is an equilibrium arrow between them. Now, which of these is going to predominate? Well, it depends on a lot of things. It depends on the solvent. It depends on the particular molecule we're talking about. But in all these cases, we can think of these things as isomers that are linked by common conjugate bases. So here's guanine. Let's try to look for tautomers of guanine. To look for tautomers, what I'm going to look for, so here, if I look at resonance structures, I'm looking for a lone pair next to a pi bond. Here, I'm actually looking for a proton next to a pi bond, particularly an acidic proton next to a pi bond. So I might focus on that H and that pi bond and draw a tautomer like this. Okay, so do you see the difference? Here, this H is on nitrogen, but here, this H is on oxygen. And they're linked because I can think about, at least in my head, think about this conjugate base having that charge spread between the nitrogen and the oxygen. Go ahead on your own and try to draw one more different tautomer of guanine. So here are a couple examples. So I could move this hydrogen up here, like I have down here, or I could even take one of the H's on this NH2 and move it to that nitrogen over here like that. So some molecules can exist as lots of different tautomers. Sometimes those amounts of tautomers are relatively equal. Sometimes it predominantly exists as one tautomer and very, very little as another. But this is what a tautomer is. It is an isomer. I'm moving atoms around, right? So no resonance arrow, equilibrium arrow, moving atoms around. But they generally are drawn from a common conjugate base. And they often can go back and forth, particularly in aqueous solution.